Hello friends, I welcome you all to my channel. This video is part of the playlist Python Basics Programming Beginner's Daily Dose, where I try to come up with videos on fundamental concepts of Python so that beginner level Python developers will get an insight of how things work in Python. In this video, I will discuss about how an object in Python is evaluated to true or false with some demonstration code examples. So let's get started. Okay, so in Python, any objects, as I have already discussed in one of my previous video, that in Python all data are objects, and any objects can be evaluated to true or false uh, based on some criteria. Now there are some constants for truth value and false values. Uh, as you know, the none constant is always evaluated to false, and we also have the two other constants false with the capital F, that is evaluated to false, and true with the capital T, which is evaluated to true. So these are the Boolean constants, and apart from this, any objects or all objects are by default are evaluated to true unless those objects or the classes of those objects have implementation of the protocol method underscore underscore length. If that protocol method returns 0, then that object will be evaluated to false, and if the protocol method underscore underscore length returns any non-zero value, it will be evaluated to true. Similarly, if any object has has implementation of the protocol method underscore underscore bool, then this protocol method should return a Boolean value which is either true or false. So depending on what it returns, the truth value of the object will be identified or evaluated. So if underscore underscore bool returns true, then that object will be evaluated to true, and if it returns false, then the object will be evaluated to false. So let's see how these concepts work in code. So we know that let's see if what is none, how is none evaluated. Let's say I do if none, I try to print none. I see nothing is printed because the condition to if was evaluated, which is none, has been evaluated to false. To check that indeed it is evaluated false, if I do negation using the not Boolean operator, if I do this and I do the same printing, it will print none. So it printed none because not none was evaluated to true, which means none was evaluated to false. Okay, and the true and false values are quite self-explanatory. I need not. Let's anyway check it out. If true, we all know this will be evaluated to true, and if not false, will be so not false. So definitely false was evaluated to false. That's why not false has been evaluated to true, and print was not false was printed. Okay, these are very basic things. Now let's come to all objects are evaluated true unless they are implement a length protocol and bool protocol. I will discuss later on. Let's see how the standard data types in Python are evaluated. So any numeric data type in Python, any numeric data type, if the value of the numeric data type is 0, then it is evaluated to false, and any non-zero value is evaluated to true. Now for float and int, definitely it is quite simple to understand that if we do if 0, this is a numeric 0, then it will be evaluated to false, and definitely this will not be printed. Similarly, it can be a float, and this will not be printed. This will not be printed. Similarly, the numeric, a zero numeric could be a complex. Now, complex number in in Python, we represent complex numbers like this: x plus yj, where x and y could be any numeric value. X and y are either int or float. So let's say I have 1 plus 1j. This is z, a complex number. This is definitely not 0. A complex number is 0 when both the real and the imaginary part are 0. But over here, both the real and imaginary part are 1. So if I do if z, then it should print z, because z has been evaluated to true, because any numeric which is non-zero is evaluated to true. Similarly, for numeric data type, we have fraction. Like, let's say I have a fraction. We have a class fraction. A fraction means in the form p by q, where p is the so we have the numerator by denominator. The fraction class, this constructor takes two arguments, p and q. Let's say I have 1 by 2. Fraction is not defined. Where is defined? Let me quickly check where is fraction defined. Fraction. Fraction. How do we use fraction? Fractions. Rational. I think we have to import some module. Yeah, it fractions. Okay, fine. Fractions. So let me quickly import fractions. And if I do fractions dot fractions, okay. Now this f should be evaluated to true because it is not 0. If I do a print fraction f, it should be printed. Whereas if I do, let's say I have this, will be make the fraction as 0. The numerator is 0. So this f2 will be evaluated to false because it's a 0 fraction. The fraction is 0. So if I do f2 and this will not be, so it was not printed. Fine. So similarly, we have decimal. So all these numeric data type, if they are 0, they will be evaluated to false, and if they are non-zero, they will be evaluated to true. Okay. Now comes truth value of sequence object. So sequence object in Python, we know the standard sequence objects are list, tuple, range, and string. Now, any sequence object, if its length is 0, will be evaluated to false, and if the length is not 0, meaning greater than or equals to 1, then it will be evaluated to true. So let's say I have a list, an empty list. If I check the truth value of L, if L, I say list, it is not printed. Whereas if I take a list with some value, non-empty list, and if I print, it will print. Similarly, it will work the same way for tuple, range, and string. Let's say a string. This is an empty string. So this will, the print statement will not be printed, since empty string meaning its length is 0, so it will be evaluated to false. So we are not having any print statement. Whereas if I do ABC and if I do print ABC, it will print ABC. So it will work the same way for range and tuple. Let's quickly check that out. If a range, let's say, how do we create an empty range? empty range. Okay, empty range, how can we do that? If I do 0, I hope this will give an empty range. uh, Empty range, so it is not printed. If I do a non-empty range like this one, it should print, because this range 1 has one element which is 0, so it is printing. Similarly, for tuple, if you take an empty tuple and try to print empty tuple, we see it is not printed. But if you take some non-empty tuple, we see that it is being evaluated to true, and so it is printing non-empty tuple. Okay. Now, truth value of collection objects. Now, in Python, the collection objects are the sets and the dictionary. The standard built-in collection objects are sets and dictionary. For a set, even though so if the sets and the set is empty set if it doesn't have any elements. So how do we check? Let's see, if I take an empty set by using the constructor set and I pass with no arguments, it will create an empty set. If I do this and print empty set, it is not printing anything. So the empty set is being evaluated to false. Whereas if I create a set from an iterable, let's say 1, 2, 3, whatever, using a list as an iterator as arguments, so the set will be created from the elements 1, 2 and 3. So this will be a non-empty set, and it should print the set 1, 2, 3, maybe some other order, some different order. So it is printing the set. So this means the set, non-empty set, has been evaluated to true. Similarly, it will work the same way for a dictionary. If we evaluate an empty dictionary and empty dict, it will not be printed. But if you take some non-empty dictionary, it will print. It will be evaluated to true. So we are getting non-empty dict. Fine. So now, so all these, since any object in Python can be evaluated to true or false, we can use them in if statement. In the condition of if statement, we can use them in the condition of while statement, and also we can use them as an operand to the Boolean operators and, or, and not. Now, what if an object? What about the custom class object? Now, for custom class object, if the class has implementation of length or bool, if it has let's create a class. Let's say some class, and let's implement a length protocol method. Let's say we do not a simple empty class which has no implementation of length or the protocol methods underscore length or underscore bool. Now, by default, it says that any object by default is evaluated to true unless that object or the class has implementation of the length or the bool protocol methods. So this class A has no implementation of length or bool, so it should be evaluated to true. If I create an instance of the class A, indentation problem there. Indentation problem, class A, this is empty, indentation problem by Mm, am I missing anything? No, not this one. Uh, okay. So what is wrong here? Okay, let's define an init uh, init that has nothing, and this should okay. So we defined a class A with with no implementation of length or bool protocol methods. Now let's create an object of class A. We have this. Now this instance A should be evaluated to true. Because by default any object is evaluated to true unless and until that the class of that object has implementation for length or bool. So instance of A, this should be printed. So it was printed. So A was evaluated to true. Now okay, let's write the code over here in the VS Code. Let's say we have class A and we have the simple empty constructor, and let's define the protocol method bool length, and for the sake of simplicity let's return 0. Now if we do this, so this class is returning 0 as length, and so it will always, an instance of this class will always, any instance of this class A will be evaluated to false. Let's see, if I do import object truthness, no, module object truthness. Why? Okay, I have to change to the directory, proper directory. Now let's run the shell. Let's run the code, directly run the file from the shell. Cancel. What is this? Okay, now we have defined a class A. Now let's, if we create an instance of A, and let's say if we do A, use A in the condition of the if statement, and we say A has, or A is empty, else print A is not empty. So if we run this, we will definitely see that the else part will execute, because if A will be evaluated to false, because the protocol method, the class A, the protocol method underscore length in class A is returning always 0. So if I run this code, we get, what is this? What is this? Object equality. Oh no, not object equality. I'm in the wrong directory. Truth. No. Truth. Okay. Now if I run this code, I get A is not empty. So else part was executed, because if A was evaluated to false. Now if I return some non-zero value, let's say -1, anything which is non-zero, now it should return it should print A is empty. If A, what happened? Oh, length should return greater than equals to 0. Okay, so if any class wants to implement the protocol method length cannot be 0. So it's part of the criteria. Okay, no problem. Let's do it 1. So we have A is over here. It should print is not empty. So we are getting A is non-empty. So now the length protocol function returns 1, which is non-zero. So any instance of this class A will be evaluated to true. So we are getting the print A is non-empty. Now let's say the same class has also, let's say we comment out the implementation for the length protocol method, and we implement the bool protocol method. Let's say we return true. So any instance of this class will be evaluated to true always. So A is we are printing A is true, and over here let's say we print A is false. So since the bool protocol method, the class A implements the bool __ bool protocol method, and it's always returning true. So any instance of the class A will always be evaluated to true, and so we will get print A is true. So we get A is true. So if it was over here, it was false. Now this code will definitely will not be as simple like this. It will depend on your use cases and on the functionality you are implementing. So this is just for the sake of understanding. False. Now in this case, now any instance of the class A will always be evaluated to false, because the protocol method __ bool is returning false, and we will have a print statement of A is false. A is false. Now I wonder what will happen if a class has implementation of both the protocol methods. If a class has implementation of both the protocol methods __ length and __ bool, whereas the length protocol method is returning a non-zero value, in that case the class, any instance of the class should be evaluated to true, whereas on the other hand the bool protocol method is returning false. In that case any instance of class A should be evaluated to false. What will happen now? I don't know. Let's see. A is false. A is false. So it is giving priority to the bool __ bool protocol method. A is false. Okay. So this was a little concept that you should remember. If for any reason your custom class needs to implement both the length and the bool protocol methods, then for testing the truth value of an object of your class, the bool, it will first check the bool protocol method. If it is there, then it will use that to evaluate the boolean value of the object. If __ bool protocol method is not there, then it will check if it has the implementation of __ length. Then it will use that. If none of these protocol methods are there, then obviously an instance of the class will always be evaluated to true. Okay. Now how do we use this truth value of an object with the if in a meaningful way, with the condition of if and while statement, or as an operator to boolean operators like and or not and or. So for using as a condition to if and while statement, let's say we have, for let's say if you want to check whether a collection or a list, let's say list is empty or not, maybe as of now you are doing, let's say I have a list like this. I will comment out this part. Let's comment out this part. Let's say you have a list, empty list, and if you want and you need to check based on the fact if this list is empty or not, you are doing something. So if length L is, you want to do something, you want to process the elements of the list only when it is non-empty. So possibly you will write the code as this and do something. Let's say process the list. You will do like this. We will check, use the length function, and if the length of the list is greater than 0, then you will process the list. So it did not print the process the list because the list is empty right now. Now this code, this thing is fine, no problem, but you could easily replace this code with simply writing if L. Now your logic is that you want to process the list only when it is not empty. So if L will be evaluated to true only when the length of the list is only when the list is not empty. So in this case also it will not print anything. So let's say I have the list has some elements, and you want to let's say print all the if L, you are printing the list, and let's say else you are printing list is empty. These are very basic examples I am demonstrating for the sake of the explanation. So if you do this, it will print the list is it will print the list. Basically, it will print the list. So instead of writing this you can easily replace this code, which will be a little compact, little shorter code with this. So this is one use case where you can use the truth value of a sequence or a collection in an if statement or while statement. Let's say you have a list in the form of a stack or queue, and you are doing something until and unless the queue you are inside the while loop, you are doing something with the queue, and that processing works only when the queue is non-empty. So let's say so with the while statement you can do while, similarly you can do while L, and you are processing something. Let's say you are removing the last element. I'm not sure if this is the function or not, and you are printing the last element. Let's say what will be the last element, maybe this, and you are removing the last element. Yes, and so in this while loop you can check as a condition whether the list is empty or not. You can use directly L. So this while will iterate until the loop is until the list is non-empty. So if I run the code, you will see remove takes exactly one argument. Remove takes exactly what was 0 given. Okay, so I think remove will take an argument which object element to remove. So let's say I want to remove the last element. Will this work? Let's see. Pop. Okay, so it did. So the loop executed for that many times when the list was non-empty. So in this way you can use the list itself as the condition to while for condition to while, and it will be evaluated to true if the list is non-empty, and else it will be evaluated to false. Now, so Similarly, you can also use, instead of list, it could be set, it could be tuple, it could be dictionary. Now let's say, how do we use uh, the an objects as an operand to Boolean operators. Let's say when we implement a merge sort, when we implement a merge sort, we first in the implementation of merge sort, we uh, we first divide the input list into two halves, and then we recursively call merge sort on the left half, on the right half, and we get sorted. So the first half is sorted and the second half is sorted, and then we merge these two sorted half into a final list. So that merge process, in the merge process, if you remember the merge process, we check. Let's say we want to merge two sorted lists into a into an output list where all the elements of the two lists will be in sorted order. So let's say we have list 1 equals to, let's say, 4, 5, and 1. This should be sorted 1, 2, 3, 1 to 10. Let's say 1, 6, 10, and 11. We have another list. Let's say 5, 9, 10. Let's say 2, 3, like this, and we want to merge these two lists into another list, so that that list will contain all the elements of L1 and L2 in a sorted fashion. So a general logic using the loop will be, let's say the output list is L. We initialize that to empty list, and we use a while. And we check. So normally what we do is we check L1 greater than 0 while and L2 greater than 0. Then what we do is, this while will iterate as long as both the lists L1 and L2 are non-empty. So they both have some elements. So in the while loop, what we do is we check if the last element. Okay, we will check the first element of the list L1 and L2, and we will compare them, and we will put the smaller one in the output list L. So L1, if L1 less than L2, what we do is, if L1, we append L1 0, and we remove pop. No, how do we remove the first element of a list? Pop removes the last element, I guess. Remove. What are the functions? We can use slice. I want to remove the first element from the list L1, so we can perhaps use slice like this. 1, yeah, they should. Okay. Otherwise, if the first element of L2 is smaller, what we do is we do the other way around. That is, we remove the first element of list L2, and we append that to the output list, and we do L2 equals to L2 1. Now, okay, but at one point of time, if the two lists are unequal, at one point of time, one list will be exhausted. So generally what we do is we again write another two while loops. Let's say while length L1 greater than 0. This means the L2 has been exhausted. There are still elements left in L1 to be processed. So we simply append all the remaining elements in L1 to the output list. So what we do is we do this. Similarly, we write the code for similar code for L2. This is basically the the standard logic for merging two sorted lists into another list. We 2 and this will be 2 and this will be 2. I hope I am right. And so finally, so let's do some printing. First list 1 we have L1. Let's print list 2 L2, and then let's print merged list is L. What happens if we run this code? What do we get? Okay, L1 was L2 is merged is, I hope the output is correct. How many elements? 1 2 3 4 4 5 9. 1 2 3 4 5 6 7 8 9. Yeah, I think it's correct. So this is the standard code that we write for merging to sorted list. Now it's so in the condition of the while, so we are using and operator. We are using and operator. Over here we are checking that both the list L1 and L2 are non-empty. So instead of this, we can simply say L1, and instead of this, we can simply say L2. If we run this code, let's see what happens. It is the same output. So this is the benefit that we are getting, that we can use directly the object as a truth value as an operand to the Boolean operators and, or, and not. So over here also we can use simply L1, and over here also we can use simply you can use directly L2, and if you run this code, we are getting the same result. So this way you can use a sequence or collection object you can use its truth value as an operand to the Boolean operators, and it will be a little beneficial. Even though code is not that compact, but still it is it is a little lesser code than the previous one. Yeah, that is all. I hope this video was beneficial to you. If you are watching my videos regularly and you have not yet subscribed to my channel, I will highly request you to support me by subscribing to my channel, like my videos and share my videos with your friends, and please do not forget to press the bell icon so that you will be notified by my future videos. Thanks for watching, and until the next video, take care and bye.